now. I'm very sorry about that. Okay, fantastic. So, apologies for the slight glitch at the start. I was asked to give a talk. This is a summarised title. The one I was given was slightly longer. Essentially on recalibrating climate change mitigation efforts. And I thought this is quite an interesting area. I'm actually active in working in this area with some Indonesian colleagues. And I thought it'd be nice to draw some parallels with the wider Southeast Asian sort of efforts towards mitigating climate change from the work that I've been doing in Indonesia. So in particular, I have an interest in respiratory health implications of electricity generation and road transport in Southeast Asia. And that's the specific area that I'm going to be talking about. And I'm going to be using Indonesia as a case study. Where I'm going to be looking at electricity generation, I'm going to be looking at transport, I'm going to be looking at how that interacts with respiratory health, and I'm going to be looking at future projections. And I'm going to try and sort of draw some parallels with the wider Southeast Asia in these areas. Okay, so why Indonesia to start with? Well, I thought, firstly, here's a nice graph which is showing the megawatt hours available per person compared to kilograms of CO2 per kilowatt hour generated. And you can see Indonesia is right at the top of the y-axis and at the bottom of the x-axis, meaning that they have they don't have anywhere near it as much electricity as, say, Malaysia or Singapore or Thailand or Vietnam. But the electricity that they do produce is highly carbon producing. Okay, so it produces a huge amount of carbon compared to the neighbours. Then if you look at essentially the investment risk, this is a risk table where green is low risk, orange is potential risk or a barrier for investment, and red is high risk or a large barrier for investment. And you can see actually, again, when it comes to investment in energy, there are some significant risks in Indonesia. You've got financial health of the utilities is quite low. The procurement of and project bankability is a high risk. And you have integrated approaches on the demand side, which are a high risk. And the only one that's is doing okay, actually, is the finance and the cost of capital in Indonesia. Now, of course, there are other countries within Southeast Asia, such as Vietnam and some of them, Cambodia, etc., that are of a similar high risk. But there is another reason that Indonesia is interesting from my perspective on the next slide, that essentially means it means that it's a bit of a no-brainer for me to want to work there. The final thing of note is that 5% of deaths in Indonesia are down to respiratory failure or respiratory disease, and so that's quite high, I think. 5% of deaths down to respiratory diseases, which of course is related to how people move and how electricity is produced. So here is the key reason for Indonesia. It goes back to the carbon dioxide per megawatt or per kilowatt hour that it's produced. Per capita, this is in 2015, I suspect it's similar today. Per capita, Indonesia was responsible for 9.2% of world greenhouse gas emissions, which is ahead of the UK. It's actually second in the world, ahead of China, and it's only the United States that are ahead of them by about a factor of 2. And that was 2015, which was somewhere here, which is close to the peak. Now, in recent years, there's been a bit of a dip, but I think we're still back on this trend of heading up. This is the overall energy consumption, and you can actually see quite clearly why that is the case. If you look here, roughly half of the total energy consumption is oil, which I think is mainly petrol in cars. And then you have gas, which is mainly electricity production, coal, which is mainly electricity production, and then hardly anything at the top here, which is wind, solar, geothermal, and hydro. This may be 95% fossil fuel energy. If you look at emissions per sector, there's some interesting thoughts here. So we've got non-CO2 emissions here, which are, I would say, primarily industry related. And then we have different emissions here going from power and heat through to industry and transport. Transport, power and heat are two relatively large parts of this section here, which is the everyday emissions. The biggest by far, however, is land use, which is this one here. Now, land use, the main reason for this, for example, here is a spike, and that's down to forest fires. So there was a spike in emissions here because of forest fires. But as a general rule, Indonesia contains 10% of the tropical rainforests in the world and 36% of its tropical peatlands. But it also accounts for 53% of the world's palm oil cultivation. And the predominant driver of land use emissions, I think, is palm oil cultivation and deforestation. It's actually the third most profitable export after coal and petroleum in Indonesia and employs 3.7 million people. It's estimated that in 2016, at this peak, 100,000 people died in Indonesia as a result of respiratory failure, and a further 60,000 from overseas, so neighbors such as Singapore and Malaysia. However, the solution is not the subject of this talk, but it is an interesting phenomenon that actually most of the air pollution in Indonesia is driven by forest fires and deforestation. But the solution is for the West, for people like myself, to stop buying products with palm oil in, but that will have a catastrophic effect on the Indonesian economy. And so that is not very easy to achieve. Okay. So moving back to electricity generation, you can see immediately the elephant in the room is coal generation. 2/3 of electricity in 2020 was produced by coal, nearly 20%, 19% by natural gas. Okay. And only 13% was produced by renewable energy. And that's the fundamental problem with the electricity market, is that there's too much coal. Looking at Jakarta, it's in the delta of 13 rivers, and 40% of its landmass is below sea level, which means that the 10 million residents are extremely susceptible to climate change driven sea rises. Okay, so that it's in Jakarta's interest, Indonesia's interest, to avert climate change. Transport is a big problem in Jakarta. There is public transport. I've been on it, I've seen it, but I think it's fair to say the majority of the journeys are not carried out by public transport, and instead it's by personal transport, usually motorbikes. Okay, so 48% of the greenhouse gases emitted in the city are from the transport sector. Okay, so most of the rest comes from the electricity sector. PM 2.5 concentration, which is a particle responsible for respiratory diseases, its particle size of 2.5 microns or bigger, or it is 4 times higher than the recommended value of the World Health Organization, and about 50% similar number to the greenhouse gas comes from the transport sector. There are more than 17 million vehicles registered for 10 million people, which means there's 1.7 vehicles per person. Now, Indonesia, on the other hand, this is for Indonesia. Last year, 123,700 deaths from air pollution. And there are 135 million two-wheelers, not three-wheelers, I'm very sorry. I should say two-wheelers. 21 million cars in Indonesia. So you can see the numbers there are a big problem. Now, the government's strategy to solve a lot of this actually is quite big. And there are a lot different policies that have been implemented over the last 2 years. Probably the most interesting from this perspective is that the Ministry of Energy have got and Mineral Resources have got a grand strategy where they want to, by 2030, have 2.2 million electric vehicles in electric cars in Indonesia and 13 million two-wheelers by 2030. And that corresponds to about 10% of the total current vehicles. So that's an interesting point. That the question is, with these targets of 10% electric vehicles, electric two-wheelers, electric cars, what's the carbon balance here? Is it a net increase or a net decrease in electricity, in carbon emissions, given that most electricity is generated by coal, which is by far the largest emitter of carbon dioxide of all energy sources? Okay. So we can actually do some full lifetime emissions. Now, this is a partially blocked out table, and I'll take you through it. Some assumptions that I've made are this: at the moment, there are 100,000 premature deaths. It's good enough in Indonesia, 10,000 in Jakarta. There are 0.6 million motorbikes, 130 million motorbikes in Indonesia, 2.4 million in Jakarta, 21 million in Indonesia. And then because we have 48% of transport from CO2 from transport, and we know that 33% in Indonesia is the case, we're going to assume that it's a similar, and it will be something of the order of 30%. Okay, so of course, if you're looking at a projection of 2030, which is when the electric vehicles are therefore, we need to think about projections for population growth. And I've assumed that the population grows from 270 million to 296 million over this period. And so therefore, the number of motorbikes, the number of cars increases by that amount. Of course, the reality is that Indonesia will probably economically develop a bit more over that period. And so this will actually be a bit higher. But as a first approximation, it's good. Okay, so we go from 0% electric motorbikes in Jakarta and Indonesia through to 10% in Jakarta and Indonesia, which means that we have 10,300 deaths go up in Jakarta in 2030, mainly as a result of population rises. And without the battery electric volts in Jakarta, we go from 10,000 to 10,900. So there's a 600 death saving by having 10% of vehicles as electric vehicles. And when you scale that up to Indonesia, it's a 6,000. So 6,000 people, in principle, as a rough estimate, really first principle, back of the envelope calculation, will not die as a result of going to 10% electric cars. So actually, that's fantastic. We look like we're in business when it comes to electric cars. So what about carbon dioxide? Typical motorbike has got a 5 kilowatt battery. A typical car has got a 70 kilowatt battery. So assuming that we use half of the charge per day, so a motorbike with a 70-mile range or something is driven 35 miles, we will need 1.35 terawatt hours and 3.32 terawatt hours additional generation capacity in a year, additional energy in order to accommodate that. And in Jakarta, in Indonesia as a whole, it's 13 and 30. So we're looking at 43 terawatt hours of additional generation. And that's huge. Okay, and these numbers are not wrong. I checked them 3 times. That actually corresponds to 300 times 10 to the 12 grams of CO2 emitted. Right, that's 300 million tons of CO2. To put that into perspective, and in the case of cars, 600 million tons of CO2. In addition, you have 33 million tons of CO2 emitted from the fact that you need to make batteries, which cost energy. Now, I mean, the good news is that as a result of not, as a result of not driving cars, you have a reduction in petrol. So you go from 656 to 590 here. Whereas with electricity production, it goes from 230 to 272. So it's actually 43 million tons of CO2 additional electricity, but a reduction of 50-ish, 60-ish million tons of CO2 as a result of not burning petrol. So actually, when you just factor all of these numbers together, okay, you just add them all together. If you replace 10% of your cars with electric cars in Indonesia with the current electricity generation makeup, CO2 emissions go up, not down, they go up. Because you have to make electricity and you have to make batteries, and that costs more energy. And let's assume that Jakarta, 14% of PM 2.5 emissions come from coal burning, and you need 16% more power. So that's 16% more coal. So it's actually 2.4% more deaths in Jakarta, which is about 240 more deaths. So it halves the amount of people. Instead of being 600 people that no longer die, we're talking about 300 people that no longer die. Okay, so there is a hit on PM 2.5 emissions as well. Now, there are alternative sources in Indonesia, which is fantastic news. It actually has the potential to generate 788, that's nearly 1,000 megawatts of power from renewable sources. Again, that's 14 times the current electricity consumption. It has, some of that comes from solar. It's in the solar belt. It's very good solar collection in these Southern Islands here, in particular on Java, which is where most of the industry and most of the people are. Okay, it's less good up here, but it's still quite good in the grand scheme of things. It also has 40% of the world's geothermal energy, and I did a quick back of the envelope calculation, and that's enough electricity to more than accommodate all of the electricity needed in Indonesia. I wouldn't say that nuclear is a good plan. This is Fukushima, some pictures, and that's what happens when you have an earthquake. And here are the earthquakes in Indonesia from the last, I don't know, 30 years or whatever. That's quite a lot of earthquakes. This is the island of Java. Okay. I would suggest that for Indonesia's sake, having a nuclear power is probably a bad plan. I wouldn't recommend it as an academic. So if we go back to